Hello and welcome to the webinar from Valentin Software. Today we will show you part one of our PV-Sol webinars with the introduction to the system planning in 2D. My name is Sixten Fiedko. I'm one of the hosts of today's show, and with me is my colleague Thomas Medeke. Hello, Thomas.
Hello, Sixten. Hello to all participants, to our guests. Thank you for joining us today. We will start with a short introduction about our persons, followed by the content of today's webinar, and then we will change live into the software to show you how it works and, of course, how it looks. Thank you.
Yes, Thomas and I, we have pretty much the same professional background. We have studied meteorology here in Berlin at the Free University. Then we worked for over 10 years in the environmental research business, followed by a short period in different environmental NGOs. And yeah, since over 10 years, we are now here at Valentin Software, and here we are responsible for technical support for the webinars and seminars, and also some database stuff. Yeah, what can you expect today? We will go through the whole program. So we will show you a grid-connected PV system with plus feed-in electric vehicle and the battery storage. During the planning, we will introduce MeteoSyn, which is the climate data selection tool. We will also show how you can create your own climate data record. Yeah, as we have a system with surplus feed-in, we have to define the demand. And for that, you can use load profiles, for example. We will also import our own load profile. Then there are different ways to determine the number of modules which you can place on the roof. One is the so-called photo plan. For that, you need a digital image and a reference measurement. And the other option is the roof view, which is it's an overview of the object you want to cover, and here you have to enter the dimensions of the object. Then we also will show you how you can configure the modules with an inverter, and at the end we will also show the polymorphic configuration, which is a configuration of module areas with different orientation or tilt to one MPP tracker, and we will show this in combination with power optimizers. Yeah, I think that's it for the introduction. We will now change live into the program. Here we are, and before we start the planning, Thomas will say a few words to the more general settings.
Yeah, that's right. I would like to do a short walkthrough through the menu bar, which you can find on the upper edge of the window. Yeah, under File, you have the possibilities to start with a new project. Of course, you can open an existing project and can work on. You will have backup copies, lots of example project, and what you can also find here under File is that you are able to do a project comparison. You can open up to 6 project files and compare about each other in form of a table, and this is very interesting and useful. And of course, you can save project, save it with another name, exit the software. If we have a look to databases, you can see that lots of databases are available for batteries, battery systems, inverters, power optimizers, PV modules, and also for tariffs. The database is maintained by the manufacturer themselves. They have an access to an online database, and Sixten will do every 14 days a database update. That means you transfer the online database to PV-Sol so that you can work with a common inverters and products. Maybe we can have a look to the PV modules database, that you can see how it looks. We are here on the left-hand side. These are all manufacturers, and here in the big window in the middle, in the center, these are the different module types. And here on the upper left-hand side, there's a lookup field, and we would like to use an LG module during our planning here, our presentation. And then you need to select the LG module. And as you can see, Here, this is a module we would like to use during our planet. And if you click the star in front of the module, then you can add this module to a favorites list. And this makes it more easy and faster to select the module, inverter, or battery system you would like to use during your planning. If you would like to add all module types from this manufacturer to the favorites list, you have to click the star in front of the manufacturer here on the upper left-hand side. Okay, that's it for the databases. Now come to the options and here to the user data. Here it is possible to enter your company data, your company address, as well as your company logo, and all this information will appear on the cover page of the presentation. If we click on Extended, on a tree view on the left-hand side, upper left-hand side, you are also able to change a folder where your product should be stored. Yeah, you can change your unit system. You have the choice between SI, US, and SI units with the American wire gauge. And you also are able here to change the current system. Well, the symbol will be adopted from the Windows system settings from the control panel. And this is a link to the right place to change it, maybe $2 or whatever. There are further options. You can start the program. If you start with a new project with a fixed system type, then you have to check this option and select the type you would like to start with. Another option is that you can look for updates, to do an update check once per day at program start. And yeah, you have also to decide if you would like to create backup copies or not. And last but not least, you will get hints and error messages on the bottom edge of the window here. For example, if your module configuration is not correct, then you will get a hint that something went wrong. Maybe either the current is exceeded or the voltage, the system voltage. But we will show this later on. Okay, I think that's it for now. Maybe some information about the different program languages. You can find it also in the help section. You will have an online help, or can also press the F1 key if you need your support. Okay, now we can start with the replanning. We have an icon bar available here, which represents a workflow, and we have to work through from the left to the right, from the welcome or project data window to the presentation window, and we have to go through each of these icons. And now we have to start with the project data.
Yeah, this is for the more general data of the project. As you can see, you can enter an offer number, the project designer, and also the customer details here on the left-hand side, and on the right-hand side, there's the first important step of the planning. This is the start of operation date, especially for the economics. So we set it to the 1st of January this year, and then we can give it a project name. And if a project image is available, we can load this, and this project image, as well as all the informations here, are part of the front page of the presentation report. In the lower part, we see the address of installation field. We can enter the address, but if the address is the same like the customer address, we just can use the arrow button here, and then it's automatically copied to the address field here of the installation. Okay, first step done. We can move forward to the second one. This is for the selection of the system type we want to plan, and then also if we want to plan in 2D or 3D, and the climate data record we want to use in our planning.
Yeah, as Sixten has mentioned in the upper part, this is to select the type of system. These are the available options you have. You can have a grid-connected system with full feed-in, where you normally will be paid for. Then there's a second option, grid-connected system with electrical appliances. That means that you try to use as many PV generator power as possible, and only the surplus will be fed into the grid. And of course, you can increase your own use by using a battery system, an electric vehicle, or a combination of both electric vehicle and battery system. Another option would be that you have electrical appliances and a thermal system. Thermal system means that you use a heat rod to heat up domestic hot water, or to run a heat pump, for example. And two further options are standalone systems with and without backup generator. And we have mentioned it at the beginning. We would like to define a grid-connected system with electrical appliances, electric vehicle, and battery system. In the area below, this is to select the type of system. Today we will use a 2D part, and if you would like to change from the 2D to the 3D planning with the detailed shading analysis and 3D visualization, then you are able to check here, use 3D design, and then the other option will be available here within PVSol Premium. To select the climate data, there are different options. We have two drop-down menus. The one on the left-hand side is to select the country, and the one on the right-hand side is to select the location. We have more than 8,000 climate data worldwide, mostly based on Meteor Norm 8.1. And there's another option to select your climate data. And this is already mentioned MeteoSyn, the climate data selection tool. And to open it, you have to click on this small globe icon. And then again, you will find more than one option. You can select your climate data from a list, as you can see here. On the upper left-hand side, again, a drop-down menu to select the country. And then you will find all available locations with further or additional information about the zip code, the global irradiation on horizontal plane, the mean outside temperature, as well as the averaging period, latitude, longitude, and of course the source of your climate data. If you have an internet connection available, you can change to the map selection. Here are different map providers available, as you can see here. And again, there's a drop down for the country, and below you can select for your location via zip code. And this is what we would like to show next. And if we enter, for example, 01454 and click on start, then the location we have searched for is marked in yellow, and the available data records in the surrounding area are marked in red. And now you have to decide if you would like to use the one next to your location you have searched for, or if it's needed, for example, to create your own or create a new climate data location. And if you would like to do this, then you have to click on a button on the lower left-hand side, create climate data for new location.
Yeah, and if we do so, then a new window will open. Looks pretty much the same like the one before. In the upper part, you can select the country. Then we have the search section here with some additional options. You also search for location and for latitude and longitude, and of course the zip code. We use the zip code again, then press start. And now a red marker appears here, and this is the marker for the search location. And then we have to click on the marker. And now the software automatically adopts the location name and the state and the zip code. And in the lower section under data, you have to select the source of the data you want to use for the interpolation of the new record. So there are different options available. First one is Meteor Norm 8. So it's a provider from Switzerland. Then we have data from the DW, from the German Weather Service. It's more or less for Germany. Then we have the PVGIST data or annual data. So depend on the location you want to interpolate. For Europe, it's PVGIST, a European project, and for some countries in Africa, etc. And then we have also annual data for North America. And then there are two commercial providers, Solcast and Solar Anywhere. You can use that ones, but you have to pay if you want to create a record. And last but not least, if you have your own data, you could select the measurement data. Then you would have to enter the monthly means of the irradiation and also temperature and create a record for that. Okay, but we use the Meteonom 8. We press OK, and then the new climate data record will be created, and it also remains in your database, so you can also use it for further plannings in the future. Okay, Radeberg now. Now we move forward to the next window, and this is for the consumption. Again, different options here. We could use the input monthly and annual consumption, for example. This is useful if you have a net metering system in your country, for example, in the Netherlands or in Poland. Yeah, then you have you feed every energy which you produce into the grid, and then you can solve it against your demand, and you can normally use the same amount of energy to cover your demand like you fed into the grid. Another option is the load profiles in individual appliances, which we use now. And again, different options. You can define individual appliances, which means you would have to create every single consumer in your home, like bulbs or fridge, etc. I think it's more or less for small scale system. For example, if you have a hut in the woods or some small home at the sea or whatever. Then we have two different load profile options. One is the from day profiles that are so-called normalized profiles. They include percentages, and if you select one, then you can enter the annual energy requirement, which you have, and then this energy requirement is distributed by using these percentages down to the simulation steps on an hourly basis here. For example, it's an annual course, and then you have the percentage 10% in January, and then you have 100 kilowatt hours in January. Then it's divided by the days, and then again distributed by using the percentages here for the daily or hourly values of the day. Okay. Then we have the load profile for measured profiles. That's more or less to import profiles, or which you get from your energy or power company. There are some pre-imported profiles here. They also can be used by just entering the annual energy requirement, and then it's again distributed according to the distribution in the selected load profile. Here, for example, it's one from the German Power Company Association. They provide annually load profiles. Okay, but we want to import one, and this can be done under new and load profile from measured values. You can give it a name here, can comment it. Then you have to define the time interval, so the resolution of the data from 1 to 60 minutes. Different options are available. We have 50 minutes resolution, and then the number of days. For example, if it's a leap year or not, 365 or 366 possible, and the start date here. The profile hours is from 2022 and starts at January 1st. And this definition defines the number of values, the 35,040 values, which you should have in your file. And this is how the file should look like. You get different formats from the power companies with a lot of information which are not needed, etc. And you have to at least delete all informations which are not needed, like the header and also the time and date, etc. You just need one column, and it's a column with the load data. The load data should be in column 1. And as you can see, it should be 35,040 rows, according to our definition, which we have made in the import window. Okay, so delete everything, save it as a CSV file in Excel or as a text file. And then you can import it. Okay, what else we do have to define is the unit. Kilowatt, watt, kilowatt hours, and watt hours are possible, and hours is in kilowatt. And the file format can be defined. It's basically to define if the decimal sign is a point or comma. Okay, so it's a comma. And then we have the table format file. We have seen our file is a one value per line, but there is also another format. This is 1 day per line. It's especially in the UK. Then you would have to select the second option. Okay, now we have to select our file. And if we have done this and press OK, and we have defined everything fine, and we get the mesh data import successful. And here we are. This is our new profile. It also remains in the database. So if you plan a similar system in the future, then you could also use this and overwrite the annual energy requirement. This also would be possible. Okay, now we press OK, and then it's adapted into our planning. It's also possible to select more than one profile. For example, this is for the household, and you could also select one for the heat pump, etc. I think, we have defined our consumption, and now we come to the PV module window, and here we have to define the number of modules or find out how many modules we can use on our roof.
Now what we have to do first is we have to select our module, and as you can see, again, 2 drop-down menus, one for the manufacturer and one for the PV module, for the module type. And now it's selected only from favorites. This means that the drop-down of the manufacturers is limited down to the dummy module as well as our favorite. And if you uncheck select only from favorites, then you will have access to all manufacturers and all module types. And if you would like prefer the detailed selection, then you will have an icon on the upper right-hand side, a database icon, and this is for the detailed selection. And then you are in the PV module database as we have shown you before. Okay, we would like to use the module from LG. And what else we can see, these are the 2 options, 16 as mentioned, the digital image with a reference measurement, and the other option with a bird's eye view from above. But of course, if you know the number of modules, you can enter the number of modules or the PV generator power directly. And this is also possible if you don't want to visualize your coverable area and your PV system, then it would be also possible to enter the number of modules, the installation type, the inclination, and the orientation, and afterwards you can find a suitable inverter and can simulate the yields. This would be also possible. You have different installation types available: roof parallel, flush mount installation with good rear ventilation. Then we have 2 types of roof integration with rear ventilation and without. Of course, you can use a mounting system on a roof in an open space, or in addition on a floating PV. This would be also possible. In our case, we have a roof parallel installation. And the inclination, this will be adopted from the rack system you use or from the inclination of your roof. The orientation, 180 degree, corresponds to south, 90 degree would corresponds to east, and 270 degree to west. Here within the 2D planning, it's also possible to use tracker systems. We have 4 types available. A single north-south axis. This means the rotating axis is orientated in the north-south direction, and the module rotates to the east and to the west. And you have to enter a rotating axis incline as well as a rotating angle of opening, 80 degrees to the east and 80 to the west in this case. The second option is the other way around. The orientation of our rotating axis is from the east to the west, and the module rotates from the south to the north. The third option is that we have a fixed vertical rotating axis and under a fixed inclination, in this case here of example of 30 degree, yeah, we will following the azimuth angle of the sun. And last but not least, we have the dual axis tracking where we can following the solar elevation as well as the azimuth angle of the sun. But in our case, we have non-tracker system, and now we come to one of these additional options. We would like to start with the photo plan options, where we load a digital image and enter reference measurement to scale the picture to determine the maximum number of modules which we can place on a roof. You have to check the box photo plan. Afterwards, you have to press the edit button, and here we are. Now we are within the photo plan option, and yeah, we have to start with loading our digital image. And this is the one we would like to use. This is the one family home without modules on a roof. And now the planning here in photo plan is separated in 3 steps. First, we have to define the vertical axis. And therefore, we have to hold the left mouse key pressed and bring this red arrow close to the edge of the building. To bring it here in parallel so that it's that's fine and matched with the edge of the building. Then we have to use the second arrow, bring it to the other edge of the building. You can use the mouse wheel to make it more accurate and to check if it's parallel. It looks good. And for what these red arrows are good for. In addition, with a 3D layer, we would like to add the next step, and with this vertical axis we can calculate the inclination of the roof from this picture, and therefore this arrows are needed. Now I have mentioned it, we would like to add a 3D geometry. Therefore you have to press to click the small cube icon, and afterwards you have to click the corner points of the roof. This is the layer in which we would like to place our modules on the roof. And here are entry fields for the eave, for the ridge, as well as for the distance from the eave to the ridge, and this is needed to scale the picture. The picture have only pixels, and we don't know how many pixels are how many centimeters or meters, and with this line we can scale it. So we have to enter, for example, 10 meters for this direction here, and so it will be automatically calculated the distance from the eave to the ridge as well as the inclination of the roof. In our case, it's around 40 degree, 41 degree. Okay, now we have to do only one further step. We need to define the photovoltaic, the solar area. Therefore, we have to click the small wafer icon here on the left-hand side, and again we have to click the coverable area of our roof. And this is our coverable area in mid blue, and here under product choice you are able to change the color of the border. Another option would be that you can rotate your module by 90 degrees from portrait to a landscape installation. And of course, you can define the module spacing in horizontal and vertical direction for the fixing material on the roof. Then we have to confirm it's okay. And the roof will be automatically covered with modules. And on the upper left-hand side, where we have started to draw our solar area, there's a center cross, and with this center cross, you are able to place a module or to center the module on the roof. You have to hold the left mouse key pressed and drop it a little bit in the middle of the roof, and so we can move it to the center. More up, and here we are. Now we have 2 roof tiles on every side, And what else we have to do? We have to remove the modules here above of our about areas. There was a small skylight as well as a parabolic antenna, and this we don't want to cover with modules, so we have to remove these modules by clicking on the green circle in the center of the module, and here we are. Now this is the maximum number we can place on a roof, and this is the number of 25 modules. There's an after view here. There are 3 tabs here: before, edit, and after. And yeah, this would be the view which you can send to your customer to show him the potential PV system on his very own roof. And now we have to adopt the data. This can be done by this button here, close and back. And then we have to adopt the data, and the number of modules as well as inclination of the roof will be adopted. What you have to enter is orientation. Yes, this should be still to the south. This cannot be adopted from our picture. Okay, that's it for the PV modules. Now we have to move on to the inverter side here, to the inverter window, to find a suitable inverter. And as often here in the software, you have different options. You can ask the software for a suggestion of module configuration. You can calculate all possible configuration, as well as you can enter your configuration by your own. If you're a pro, then it would be possible here via this drop-down menus, the left one again for the manufacturer, the right one for the inverter type, and below you can then enter the MPP and the modules per string. This also would be possible. If you would use the first option here to ask a software to suggest the configuration, it makes sense to limit down the huge number of inverter types. Yeah? If you click here on this link, inverter selection, then you are able to check the boxes here or uncheck the boxes for all the potential suitable inverter types. There's also an action bar here on the upper side, and yeah, the 2 icons here on the upper right-hand side. These are available to deselect your selection or to select a suitable inverter types. And if this is done, you have to confirm with select, and then you have to click here. These buttons suggest configuration with the arrow down. And then you will get immediately, in this case, because it's a small system, your configuration. In our case, it's an SMA Sunny Tree Power 6.0. It's an inverter with 2 MPP trackers. And the first one, you will have 13 modules in series, and for the second one, only 12 modules. Here you can see what is the design range. We need a minimum of 5 modules in series, and the maximum is 19 modules in series. And if we change it, for example, to the lower number here for 4, then we get immediately information that something went wrong. And you can see it also here in our information bar on the bottom edge of the window. The specified number on our roof is 25, but we have only configured 18. And another problem is that we do not reach the MPP voltage range from 125 volts. We have only reached 106.4 volts. And if you click on this triangle here, attention triangle, then you can see, this is what we have reached, 106, and the design range starts at 125 volts up to 800 volts. Yeah, so we need to change it back to 13, and then everything is fine. This here on the upper right-hand side is the second option. We have pre-selected 39 inverters from a total selection of 68 SMA inverters, and yeah, from this 39 suitable inverters, the number of configuration will be calculated. And as you can see, in total we have 886 configuration, and the first one here, this is the one the program has or had suggested before. Okay. Yeah, I think that's it for the module configuration, and we come to the electric vehicle.
Yeah, looks familiar, I would say. Yeah, we have two drop-down menus, and one is for the manufacturer and one is for the electric vehicle. In our case, we want an Audi, and this should be a sports spec with an AC charging at 11 kilowatt. As you can see, there are different types in the list with different charging modes, DC or AC charging, sometimes different power they can charge. Okay. If we have selected the right one, then we can also define the number of vehicles we have here in this field. And in the lower part, in the section use, we have to define the desired range we drive per week. I think we let it at 350 kilometers. And then there's a small matrix with the different days during the week and also the hours on a day. And this is to define the times which we are at the charging station. Yeah, we can set or remove hooks. If we have set a hook, then we are at the charging station. If we remove it, then we are away. Now we can copy these values. We can also copy these values for all days. Yeah, if we press this option here, then we have just copied it to the different single days. And on Saturday, we define it a little bit different. Make a short drive in the morning. I think we should also set the hook at 8 a.m. Yeah. And then for Sunday, we make a short trip in the evening. Okay, that looks good. What else can we see? On the left-hand side, there is you can see the group 1 as a kind of a tree view. Here we can define different groups. This gives us the option to select the different types of cars. If we have different types of car, then we have to define different groups. Or if we have, for example, the same type of car, but we are at different times at the charging stations or drive a different desired range, then we also have to define an additional group. So we can copy it or create a new one by using this icons here or buttons above the tree view. And then we have an option here on the charging station. It's for the charging mode. There's standard and PV optimized available. What does it mean? Standard means our car comes to the charging station and then the battery of the car is charged. Even if no PV energy is available, then it's charged by the grid. And if you select standard, then the battery of the car is loaded up to its full and fully charges. If you select PV optimized, then the battery is also charged. Doesn't matter if PV energy is available, but also up to a certain charging state, and this is state that you can drive the next trip safely. Standard fully load if no, and PV optimized only to the point that you can drive safely. Of course, if PV energy is available, then it's just charged up to the limit. Okay, I think that's it for the electric vehicle. Now we come to the battery system. Same principle, we select the manufacturer. In this case, we select SMA again, and then we have to select the corresponding or battery system with a battery inverter, or if we have a hybrid inverter, if we have selected a hybrid inverter in the inverter configuration, then we would here have to select a combination with a hybrid inverter and a battery. For example, here this would be, I think, some of the smart energy ones, smart energy plus BYD. So you find the combination, But in our case, we select, I think it's a Sunny Boy storage with then BYD system here. Okay. Again, you can increase the number of battery systems here if you like. And that's it for this window. Let's go to the next one, and this is for the cables. This is basically to determine the cable losses. You can enter total loss if you like, or you can also select the option in detail. Then you have to enter the cable length and cable cross sections, and the software then calculates the cable losses out of this.
Yes, and you have two parts. You have AC cables here in orange. This is the distance from the inverter to the meter. And you have the DC cables. These are the green ones. And yeah, you need to enter the one-way length for the AC cables. In our case, it's 10 meters. And so you have to select the cross section of your cable. And you have the choice between the material, copper, and aluminium. And with this calculator, you can calculate that can calculate the cross section that the losses are closer than lower than 1%. Okay, then we have to go down. Here's the part with the string cables, and you have to define this for MPP tracker 1 and MPP tracker 2. Or if the length is the same, you can apply for all MPP trackers. And please keep in mind, for the string cables, you have to enter the go and return length. For the AC cables, we only have to enter the one-way length. Okay, so that means we have to enter here 20 meters, 4 millimeters square in copper. And we would like to apply these for all MPP trackers because it's not only one roof, it's not a separate building, a garage where the distance is higher. What else we can do here? We can add circuit symbols, as you can see here. This is an option. We can remove a feed meter because we have a bidirectional meter in our case. And yeah, there's one reference point. This is marked with this A here, where we have our consumption, and we can add circuit symbols in front of these point, not and behind of this point. And the upper part is to add circuit symbols in front, and this one here is after the load. That's very easy. You have to click the button here, add circuit symbol, and then there are different options available: circuit breaker, fuses, load break switch, and so on. And you have only to press on add. You have to close, and then it's here added. And in our case, it's behind of our meter. If you would like to change the position and in front of the meter, then you have to mark the circuit symbol, and then you have to use this arrows here to bring it in the correct position. And now it's on position number 1. This means that it's before the meter. And so it works. So you can define your cable plan by your own. I think that's it for the cables. We can move on to plans and parts list.
Yeah, and there's nothing much what we can do. It basically depends on the selection we have done so far. Batteries, modules, etc. You can have the option to use a legend and define where the legend should be placed here, or if you want to have a drawing space or not. You can remove it, for example, here. Then there are some blend properties. So if you want to have it in landscape or portrait orientation, if it should be colored or not, and also the legend, the color of the legend. This one can be exported in a PDF, PNG is a picture, or SVG, which is a vector graphics format, which then can be opened in a CAD program if you would like to work with it or add something there. Then we have the parts list, also depending on the definitions we have made. Can decide if one of the if they should all appear in the presentation, at least. The electric vehicle, it's not, in my opinion, not part of the PV system. So we remove it here in the visible column. So we remove the hook, and then it's out of the presentation. You can also edit item numbers if you have specific item numbers for example here the modules, and also the software will also remember these numbers if you select the module in the future planning. You can also add additional items here with the option new item. And then next item is in the list, and then you have to define it, etc. This one can be exported into a CSV file, which can be opened in Excel, or you can copy the whole list here and paste it into Excel or whatever, Word, etc. Okay, so that's it for the list and the plans. And now we come to the financial analysis. And in the upper part, we have to define the costs of the system. And then in the lower part, we hopefully have some income, which also has to be defined.
And to enter the costs and the assessment period, we have to click the Edit button. And here we are on a page of the general parameters with the assessment period. In Germany, it's normally 20 years, 20 complete years plus a year of installation. What else we can do here? We can take it into account the loss of the value of the money. 1,000 euro now is not the same in 1 or 5 years. It can be taken into account. Then you have the option to mark how you have entered your values, or the values net or gross. There will not be a change. If you change here from net to gross, there will not be added the taxes or something. This is a reminder if you open your project file in 1 or 2 months or 3 months that you know, oh, I have all entered here net or gross. To define the costs, we have to go to the next window, to the income and expenditure window. And here in the upper part, this is a placeholder, 1,500 euro per kilowatt peak. You can also enter it in total per euro. And if you would like to have a more detailed entry, then you have to check here on the upper right-hand side, detailed entry, and then you can add positions, for example, for your PV installation, your battery system, as well as for inverter, and so on and so on. All this is possible. We would like to have 2 positions, the PV system itself, as well as the battery system. Yeah, and then we have to enter here the cost. It's 10,400 euro for our PV system and 6,300 euro for our battery system. And if you would like to use, you can also here define on next to the right the period of use. How many years your component will be run. In a battery system, maybe we have plug and it will run for 20 years. But in case of inverters, it could be that you have to reinvest in your system, to reinvest in an inverter. And if you would like to take this into account, you have to add the position with inverter and have to enter a period of use, for example, 15 years. And then in the 16th year, it will be reinvested in a second inverter. Okay, if we go back here to income and expenditure, it is also possible to enter here incoming subsidies. We can define outgoing annual operating costs. You have 3 options available. You can enter euro per year, euro per kilowatt peak and year, or as percentage of investment per year. And this is what we would like to do. We would take into account 1% of the investment per year. It is also possible for all these to define an inflation rate, and if you want, you can also enter it more detailed, your operating costs. If you have to pay, for example, an insurance, or you have to pay a rent for your roof, All this can be entered. You can enter it here in operating cost, or you can also use this as further option, annual consumption cost, outgoing other annual cost. All this is possible, but it's not needed to fill all of these entry fields. Now we come to the financing. We would like to finance our system. Up to 3 loans in parallel are possible. We have only one loan with 100% loan capital. We have a free initial period of 2 years. The term is 10 years, and the loan interest should be 3%. And we would like to pay it back quarterly. Further options are monthly, half-yearly, and yearly. And of course, you can also take into account tax. Therefore, you have to check allow for tax. It's also possible to taking into account depreciation, linear as well as digressive. But we recommend to ask a tax consultant for that. And this is the reason because we uncheck this option. Okay. I think that's it for the general parameters, and now we have to look about the different feed-in concepts and about our feed-in tariff and from the tariff to see if we get income or not.
Yeah, that's right. First we have to define the energy balance or feed-in concept. In our case, we have the surplus feed-in, which means we first use to generate the PV energy ourselves, and the rest is fed into the grid. And then there's the other option, the net metering, which I told you before, as we defined the demand of the system. And then you feed everything into the grid, and then you just save money because you can use the same, in most of the case, the same amount of energy from the grid, which you have fed into the grid and to cover your demand. But in our case, it's surplus feed-in, so we select this option. And now we have two different incomes. One is we fed into the grid, and we have a feed-in tariff, and then we get some money for the energy we feed into the grid. And the other one is we save money because we use PV energy ourselves and pay less to the power company. Okay, for the feed-in tariff, we first have to select the feed-in tariff. So we remove the current ones, then we go to add. And here in the database for Germany, of course, we have some available, some tariffs. If you in your country have, of course, you have our other tariffs, then you can define them yourself here on the new. You can add a new one and then enter the prices you get for feed-in. Okay, let's take a look at the tariffs. On the left-hand side, you can define the country, the city. If for a specific city, you can give it a name. And in the lower part, there's the more important one, the valid from date, and also how long it's valid, the payout duration here. In our case, it's 20 years. And on the right-hand side, there are the prices we get per kilowatt hour for the different, in our case, tariffs steps here, but of course depend on the regulations in your country. Okay, then we close it here. We select it, and then it's in our database. Then you can define an inflation rate. It's not the case in Germany, but if you plan in the UK, for example, then there could be an inflation rate, of course. Okay, then we have the from tariff. Click here on select, and then most of the cases you have to define it yourself, because every of the customer have their own tariff, and it works similar to the feed-in tariff. Create a new one, select the country, city can be entered, and then you can select the energy supplier. If it's not available, then you can create your own one here. For example, right, and then you, and then you can enter the name of the power company. can give it a name and also define if it's consumption, is it a residential or corporation, but this is not just for information, doesn't matter. You can also define a base price, which also doesn't matter, but because you have to pay it anyway and don't save it, at least the important information are on the right-hand side again, and this is the energy price you have to pay here. You can also define different tariff steps or periods. For example, if you have different prices for different periods, if you add it, then you can enter another one, and then you have tariff period 1 and tariff period 2 marked with number 1 and number 2. And then in the lower part, we can see this matrix for the different months here, and then here also the hours, and then we have to define which tariff is valid. So mark it with your mouse, draw a frame here, right click, and then select tariff period 1 or tariff period 2, and then you can see this is how you can define it. I think up to 12 is possible here, up to 12 different periods. Okay, but in our case we have just one, so we remove it or we just delete the whole file. Select this one here, it's already created, select it. Let's take a look at it. Okay, we have 35 € per kilowatt hour, which we probably save. Okay, that's our tariff, and we can define, of course, an inflation rate here. Well, it's moderate at the moment here for this planning. So that's it for the financing, and now we can come to results. So we have defined everything in our planning. Press simulate, and then the overview page appears with some information about the generated energy and some economics.
Yeah, the technical quality of your system we find on the upper right-hand side with the PV generator power you have produced. It's around 8,700 kilowatt hours in the first year. Then you will have the specific annual yield. This is around 1140 kilowatt hours per kilowatt peak. Also the performance ratio is visualized and grid feed in per year. And on the upper left-hand side, this is a revenue or saving we have. It's around 2,200 euro per year. And the accrued cash flow balance, the cash flow after our assessment period of 20 years, this is more than 32,000 euros. Below, this is the balancing graph. Above of the zero line, this is what comes in, what we have in our system. This is, of course, PV generator power, as well as battery energy, and there's energy from the grid. And below of the zero line, that is the information where we have used our power for. This is to cover the consumption, to charge a battery, of course, to charge our electric vehicle, and sometimes we need to feed our energy into the grid because we cannot use it. And here are further graphs available, how the PV energy is used for every single month, and also how consumption is covered. We have a higher amount of PV energy during the summertime and the lower one during winter time. Here's the amount of energy from the grid is higher than during the summertime, of course. And this one here, this is how the total consumption is covered, and the total consumption means that here's also the battery as well as the electric vehicle charging is seen as a consumption. Really close information about the simulation you will find in the tree view under simulations. Here are different parts: PV system, appliances, electric vehicle, and battery system. And here you can see how is the specific annual yield, what is the PV generator power, and then the more interesting information about the direct own use, the battery charge of the electric vehicle, and what we have to feed into the grid. and the own power consumption is here close to 68%. Same for the appliances. We have the household consumption of 5,000 kilowatt hours per year. And in addition, the charge of the electric vehicle to drive our mileages. And yeah, so that we have a total consumption of more than 10,000 kilowatt hours. And from this, we can cover more than 55%. As you can see, 3,610 is covered by the PV power directly, and 2,086 is covered by the battery net, and covered by the grid is only 4,500 kilowatt hours. Yeah, and then further information about the electric vehicle, how many mileage we can drive with solar, and another information is how is a part of the battery system, a battery charge in total, as well as covered by PV power, consumption covered by PV power. Yeah.
Okay. Yeah, then there are different other graphs available, and also previous system energy balance, where you can see what's coming into the system and where is it going. Basically, you have the global radiation income, and then some gains due to ground reflection and orientation and inclination of the modules, and the rest are all losses due to the efficiency of the modules and the inverter, etc. Then we have the financial analysis with all the information we have entered, and what you can see here is the minimum system operation period. It's about 9 years. So after 9 years, we are going into plus. And in the lower part, you can see the income here. The first one is total payment from utility in first year. This is for feed-in. It's about 230 euro. And the savings are about 1,990 euro per year. This can also be seen in the cash flow table, where the values for the whole assessment period are shown, in combination with the cash flow, the accrued cash flow. There's also a graph for that. That are the results. Okay, what is left is the presentation. And on the front page, we should see all the information which we have entered at the beginning of our planning. That's customer information, picture which we have selected, etc. Then I can zoom in a little bit with our mouse wheel. It's a system overview about the selected climate data record. Then first information about the generated energy and how is it used, and so on. All the information which you can also see in the results window can be in the presentation. You can also decide what should be in and what should be out. Here are no further options. There's the tree view, and again, by setting a hook, then it's in. By removing the hook, it's not in the presentation. You can also save this as a template. And what else can we do? We can select additional languages and compare to the program languages here. For example, Swedish is available, or Hungarian, etc. Okay, the presentation can be printed out. You can save it or export it to a Word file or PDF file. Okay, that was a full planning. I promised you that there are 2 different ways to determine the number of modules on an object. The photo plan we have already shown, and now we come to the roof overview or roof view. And therefore we have to define a new module area here. So select new, and we have a second one here. Click on this module area. First we have to select our module. It's our favorite again. And now we select graphic coverage. Set the hook here and click on edit. And then the new window will open. And here we have to enter the dimensions of our roof and also select the roof type. or object type. And yep.
Yeah, the roof visualized here is a default roof, and if you would like to start with a new one, you have to press the small trapezium icon here on the upper left-hand side. This is to create a new 2D object. And yeah, for our roof, we have 3 standard forms available: a rectangular, trapezium, as well as a triangle. In our case, we have a saddle roof, a gabled roof, so it's a rectangular, and you have to define the dimensions. We have a 10-meter eave, and the distance from the eave to the ridge is close to 5.3 meters. And in the middle on the left-hand side, you are also able to define the border distances. This can be done for all borders in once. But another option would be that you uncheck this option, and then you can do it separately for each border. And in our case, we don't want to have a border distance at the ridge, so we set it to 0. Okay, then I have to confirm it's okay. Again, I have to confirm, and then I get a remark here that the previous roof will be removed. Okay, we confirm this, and this is the roof we would like to have. 10 meters eave, 5.3 meters is the distance from the eave to the ridge, and we have a border distance for the gable end west, gable end east, and for the reef from 20 centimeters. Below of this graph, we have to define the roof orientation. This should be 270 degrees. That means it's orientated to the west, 270. And the roof angle we know from our further planning here with photo plans around 40 degrees or 41 degrees. Okay, now we would like to add the marked areas, the restricted areas. As you can see here on the upper right-hand side, we have a small skylight as well as a parabolic antenna. And to define these objects, you have to go forward here to the next node, to the restricted areas. And then again, you have to click the small trapezium icon, and here we are. We have a rectangle for our skylight and a circle for our parabolic antenna. We would like to start with our skylight. It's 0.4 by 0.6 meters. It's also possible to change a reference here if you would like. And then we have to confirm it's okay. And our skylight is placed at a point of origin, and point of origin means the lower left edge of our roof. And we can enter the end position here via entering the X and Y coordinates to bring it on the right position. And let's have a look. It's 7.9 and 3.6 meters in Y. 3.6, and here we are. And to add the parabolic antenna, we have again go back to restricted area to the node here, and again press this small trapezium, and now we have a circle, and the radius should be 0.2 meters. And again, we have to confirm it's okay. It's placed in a point of origin, and you have to enter the X and Y coordinates for the correct position, and it's 8.5 by 4.4 meters. Last but not least, we have to define the PV area. So we have to go to this node here, press this small trapezium, and again, according to the standard form, to the form of the roof, you have again here this forms available. And the easiest way, of course, is if we say fit to the roof area, then the covered area is as big as the roof is, and here we are. And below of this, you have to define the installation type. If it's roof parallel, roof integrated with or without ventilation, and if it's a flat roof or an open space, then you can also select mounted or mounted open space. We again have a flush mount installation, and the orientation is 250 degrees. The module inclination is 41 degrees. And yeah, to place the modules on the roof, you have to do a right mouse click here within the coverable area, and then you can cover automatically. And if you would like to edit your PV area beforehand, this means that you can decide about the installation type, if it should be a horizontal or vertical module installation, and if you would like to take into account the horizontal and vertical distance between the modules, then you have to edit it beforehand. Yeah, then we have to confirm it's okay, and here we are. Now it's the same installation as we know from our photo plan installation, and last but not least, we are able to center the modules here. There's another option, position of PV modules, and if we enter here, for example, 0.45 and 0.2, then it's center, and it looks like our planning before. Yeah, that's it for the graphic coverage. We have also 25 modules. We have no errors. This means that our modules are not in one of these restricted areas or in the border. And everything seems to be fine, and we can do a configuration with both module areas together.
Oh, that's right. So we change to the inverter window here. And if we want to configure both areas together, we first have to mark them. So we press our control key on the keyboard, hold it pressed, and mark the second module area. Then they are both marked in kind of blue. And above this selection, we see configure module areas together. So we have pressed this, and then they are kind of merged. But they are considered separately. So if we now search for an inverter configuration, then both module areas have to be configured to separate MPP trackers. So the software only considers inverters with 2 or more MPP trackers now. If we want to have both module areas at one MPP tracker, we have to select the polystring configuration. So we have to do it manually here. So that's what we want to show now, and we want to also use power optimizers for that. In our case, we select Solar Edge. Solar Edge optimizers here. We have about 15 kilowatt peak for both areas. So if you select the SE15K, which has about 15 kilowatt. This one here. Okay. Then we have to use power optimizers if you work with Solar Edge. And there are again different manufacturers available. Solar Edge inverters can only be used with Solar Edge optimizers, so we have to select Solar Edge here. And finally, the power optimizer we want to use, we have a 305 kilowatt module, so we use the 320 worldwide here. So then we can see for module area 1, we have 25 modules. Now we have 25 optimizers. So for every module 1, one module in parallel and one module in series. And here we have to select the module. So that's the first sub row. So we have to add a row. Here again for the module areas, 25 optimizers. Because we have 25 modules, one in series, one in parallel, and then we have to select module area 2 here. And that's how you can define it. If you have smaller substrings, you sometimes have to connect the strings in series. Then you can set here the hooked that connects strings in series, and it's not the case for this system because then we exceed the maximum output of strings here. So we use 2 parallel strings for that. Okay, I think that's the end of the planning here now. That's the things we wanted to show you. If you need some more information about our products, please take a look at our website, www.valentin-software.com. If you have some questions afterwards or some remarks, please write us an email to hotline@valentin-software.com. that's it from my side. Take care. Bye-bye.
Yeah, again, thank you for your time you have invested, and if you have joined us today, please keep in mind in 2 days on Thursday we will show the 3D visualization. We will focus on the 3D part and the different planning modes you have. We plan with predefined buildings where you have to enter the dimensions. We show how to plan with own maps, with Bing and Google Maps, and also the import of 3D models will be shown. Okay, thank you very much again. Take care and goodbye.